Colby, 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 math.com.
Today in class we looked at models for perfect squares and square roots. Problem number 9 says the model below represents a city block in Gavin's neighborhood. So all of this yellow area is representing one city block. Each day, Gavin exercises by jogging around the block several times. In the model, each small yellow square, so one of these yellow squares, represents an area of 400 square feet. How many feet will Gavin have jogged after one complete lap around the block? So the first thing we need to understand to solve this problem is that the information we're given is referring only to each of these small yellow squares. So I'm going to blow this up bigger. If I take one of these yellow squares and make it larger so I can take a closer look at it, we're given that the area is 400 square feet. And we know that for any square, the sides are the same, so we could just use S to represent the side length. But the expression, the equation for any square would be side times side equals area, or side squared equals area. Or in the case of our square, side squared equals an area of 400. What we learned today in class is if you want to solve for the side length, the inverse of squaring is taking the square root. And so if I take the square root of 400, I'll find out what the side length is. The side length is equal to the square root of 400. And you find a square root by thinking, what number can I multiply by itself to give me that area 400? And you're not expected to have these memorized at first. That will come with experience. But if you just pick a number like 10, 10 multiplied by itself is 100. So we need to go higher. You may have 12 times 12 memorized. That's 144. So we need to go higher. If we go, we went up a little bit, or we're trying to get to 400. If we go up quite a bit to the next 10, like 20 times 20, you multiply those, you'll see that that is, in fact, 400. And so 20 is equal to the square root of 400. This process of trying different values is the same process you'll use on a problem like number 7 on your assignment. Once we know the side length is 20, so we know each side is 20 feet, so we can start to get an idea of the dimensions of the city block. Because if each side is 20 feet, then when you start to imagine Gavin starting at some point and running around the block one time, each little square he runs past is 20 feet in length. 20 feet, 20 feet, 20 feet. It's just a question of how many 20 feet segments make up one side of this large square block, and then realizing that there are 4 sides to that square. So try to take it from there and solve the rest of this during the pause, and then come back and see how you did.
Paused.
If I count up how many of these little yellow squares make up one side of this large square block, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of these little yellow squares. And so 20 times 15 feet, I shouldn't do it that way. I mean, it would be fine that way, except it's more understandable if I say 15 times 20 feet, because we have 15 squares and each one has a side length of 20 feet. That would be a total of 300 feet. So that's the distance to run if I'm just talking about running all the way from this vertex to this vertex. That would be 300 feet. But we know that the city block itself is a big square, and so each side is 300 feet. And so to go all the way around the city block, it would be 300 times 4, each side being 300 feet. 300 quadrupled is 1,200 feet, and that would be the solution to this problem. I hope that helped with the assignment. I'll see you tomorrow.